Hello dear participants, I welcome you all here in this lecture number 23. Title of lecture 23 is Descriptive Statistics, Reading and Interpretation of Dispersion Values. As we all know that in the previous lecture, lecture number 22, we tried to understand the meaning of concept dispersion, and also we tried to understand the meaning of different measures of dispersion like range, quartile deviation and standard deviation. This lecture will be dealing with the reading and interpretation of the output or the results. Objective of present lecture is to make you familiar with reading and interpretation of dispersion values which we compute using MS Excel and S.P.S.S. So here are the measures of dispersion, namely range, quartile deviation and standard deviation. So let me start first with the first measure of dispersion, that is range. So range is the difference between largest and smallest value in the data set. In the previous lecture, we have already discussed about the meaning of range, and we also have seen that how to give proper meaning to the values associated with range. Now let me take you all to the data set, which data set we already have used in our lecture number 17, where we tried to understand the procedure to compute different central tendencies, procedure to compute different partition values, procedure to compute different dispersion values, and procedure to compute different distribution or shape values like skewness and kurtosis. Same data sets, same sample data set we are going to use here in this lecture too. Now here in a very brief way, I'll explain you the procedure first, and then we'll go for the reading and interpretation part. Now here to compute range, first we need to compute max value and min value. And for that, simply I'll put equal to sign and I'll use one function max, then I'll select the range and I'll press enter. I'll get the max value. Then for the mean, again I'll put equal to sign and I'll use one function min and I'll select range and I'll compute min value. Then there is no specific formula for the range in inbuilt formula for the range in the MS Excel. So here what we need to do here, that to compute range here I'll have to put equal to sign, then I'll have to select a cell associated with max value, then I'll have to put minus sign, and then I'll have to select the cell associated with min value. So let me do that. After selecting these different cells and putting that minus sign in between these two values, if I press enter, I get the range. Now to compute range for the remaining variables, simply I'll select all these three cells and then I'll drag this to the end and I'll get the max, min and range values for all other variables too. Now after getting the results, now let me take you all to the reading and interpretation of the range. And here also, first we'll consider the nominal variables, then we'll consider ordinal, and finally we'll consider scale, and we'll see that how to read and interpret the values associated with range. So here is the nominal variable. Two variables are here, gender and gender C, and as already I mentioned in the previous lectures too, if we are having alphabetical responses, if we are having the string data, then we are not going to get anything here. In most of the cases we get the error message, but here we have got one value and that value is 0, but this 0 has no meaning. So we cannot give proper meaning to these numbers here because this gender is a string variable. Now come to gender C. If you remember how we assign code, so far the gender that variable is concerned, we have assigned 0 as a code for male and we have assigned 1 to female. Now what's the formula for range? Range is equal to max minus mean. Now which number is the maximum number out of these two assigned codes? 1 is the maximum number, and which one is the minimum number? That is 0. So these numbers, these assigned codes been considered considered here as a max and mean. It means we cannot give proper meaning to these numbers because they are simply the codes. They are simply the assigned labels actually. Fine. And if I deduct 0 from 1, definitely I am going to get 1, but I cannot give any meaning to this. No meaning. So when we are having the nominal variables, we cannot apply range on such kind of variables. Now let me take you all to the ordinal variables. Here also the story is same. We cannot give any meaning to these zeros. No meaning. Fine, because this is a string data. Now if you remember, we have assigned codes in such a pattern that code 1 we have assigned to very satisfied, code 2 is assigned to satisfied, code 3 is assigned to neutral, code 4 is assigned to unsatisfied, and code 5 is assigned to very unsatisfied. Now if we'll go back to the formula of range, range is equal to maximum minus minimum. So which code is the maximum? Because all this data is a coded data, all they are the coded responses. Now in these numbers, which one is the highest number? That is 5. That's the maximum value. And which one is the lowest value? That is 1. So 5 minus 1 is equal to 4. That is why here max is 5, min is 1 and range is 4. But here also, can we interpret this thing? Can we give some fruitful meaning to this 4? No, we cannot give meaning to this 4. Is it like that? That in this distribution, in this data, the distribution is like this. Fine, here is something 5 and here is 1 and the gap between these two extreme numbers is 4. How can we say the number of observations are 100? There are 100 respondents here. So it becomes very difficult to give meaning to the this range value here in the ordinal variable. So range is not applicable to ordinal variable and nominal variable both. Now let me take you all to the scale variable. In the scale variable, here is my scale variable age. Now in this my data, this distribution of this data, here is my minimum value 14. So 14 is here, 68 is the maximum value, that's fine. And the range is 54, it means the difference between these two extreme values is of 54. That's fine, I can give some meaning here. I can give some meaning here. But again, if I consider age C, here again, if you remember, we have assigned codes like 10 to 20 years, 20 to 30 years, code number 2, 30 to 40, and so on so forth. So maximum value is 6, minimum is 1, the difference between 2 is 5. But here we cannot give proper meaning to this 5, but we can give proper meaning to these numbers. It means we can apply range to scale variables only. The numbers, the values, the output or the results here is a result where we can give some meaning. If we are having the nominal or ordinal variable, don't treat those variables with the range. We cannot give proper meaning using those outputs. Fine. Now let me take you to the further slide. Now here is the maximum is 68 and it is located here. Correct. And here is the minimum, that is 14, and here is the range in between this, and this range is known, and this range in numbers it is actually 54. The difference between these two extreme values is 54. All other responses are in between this range. Fine. Here is the maximum value, here is the minimum value. Now if we go ahead, here is the maximum and here is the minimum value. So this is the way that we interpret results for the range. So for the scale variable is concerned. Now let me take you all to the quartile deviation. What is quartile deviation? Quartile deviation gives the average amount by which the two quartiles differ from the median. What does that mean? Quartile deviation simply tells me that how far my both the quartiles are far from the median. Average amount by which the two quartiles are differ from this median. So how far both the quartiles are from this median point. Fine. So that's the meaning of quartile deviation. Now let me take you to the same sample data set and let me again compute third quartile, first quartile and quartile deviation. To compute third quartile, simply we use the function or a formula quartile, then we select the range and we put a comma and we put number 3 because we are going to compute third quartile. Simply if I press enter, I'll get the result. For quartile 1, same procedure is there, only instead of 3, I'll use number 1. So if I press enter, then I'll get the result. Now for the quartile deviation, I'll have to arrange my own formula. How it works? In MS Excel, there is no inbuilt formula for quartile deviation. And if you remember, the formula for quartile deviation is Q3 minus Q1 divided by 2. And as we know, Q3 we already have computed here, Q1 we already have computed. Then how to compute quartile deviation? For that, I'll have to put equal to sign and I'll have to arrange one bracket, and in the bracket first I'll click on the third quartile cell, then I'll put minus sign and then I'll click on the first quartile cell, then I'll close the bracket and then I'll divide that part by 2. Always remember, sometimes if you go like this Q3 minus Q1 without this column divide by 2, then usually this divide takes first place and then it goes for the minus thing and it may lead to the wrong result. So always remember that whenever we are placing the formula is equal to sign, then in the bracket first quartile 3 minus quartile 1, then close the bracket and then divide it by the 2, then we are going to get the proper result. Now let me go ahead, if I press enter, I'll get the result. Now to compute quartile deviation for other variables, simply I'll click on all these 3 variables and I'll drag it to the end. As I drag it to the end, all the formulas been applied for the other variables too, and quartile deviation, third quartile and first quartile been computed here for other variables too. Now let me take you all to the reading and interpretation of quartile deviation. Here also, first we'll consider the nominal variable. Let's see. Again, here we are having the error message because this is a string data. Now let me take you all to the gender C. Now third quartile is 1, quartile 1 is 0 and quartile deviation is 0.5. What does that mean? This gender C, here is our data. Now if here is the data, here is the minimum value, here is the maximum value, and say that here is Q1, here is Q3 and here is Q2. This table, this result sheet, it tells me that Q3 is 1, Q1 is 0 and quartile deviation is 0.5. It means the distance between these two quartiles is 0.5. Mathematically it seems to be good. But we cannot give proper meaning to this. The reason is that here is the minimum value. Whether the minimum and quartile 1 are same, are they? Whether the maximum and quartile 3 are same, because here they looks to be same. And moreover, simply this 1 is actually assigned code to female and this 0 is actually assigned code to male. Then we cannot give meaning to this result. 0.5 means what? 0.5 means what? What is the meaning of gender? Gender means it simply tells us the gender, male or female or transgender. Fine. So far the nominal variables are concerned, we cannot apply quartile deviation here. No, we cannot apply. We are not able to give proper meaning to the result. So never ever apply quartile deviation on the coded normal variable. Now let me take you to the ordinal variable. Story is more or less same here too. Here is the error message because this is a string variable and here is a static. Now again the quartiles are like this. Here is the max value, here is the mean value, and here is Q1, Q2 and Q3 equal 4 parts of the data. Correct? Here is the 2, here is 3. Again mathematically that's true. Averagely 0.5, both the quartiles, their distance is 0.5 from the median. Mathematically that's true. What about the meaning? Can we give proper meaning to this? No. Again, a very important point, we cannot apply quartile deviation on ordinal variable. No. And the reason is that we cannot give proper meaning to this. What is the reason? All these numbers are, they are nothing but they are assigned codes. Whenever we are having coded data or the categorical data, don't apply quartile deviation. Then to whom we can apply quartile deviation? Simple answer is if we are having the scale data, scale variable or the continuous frequency distribution. Fine, then only we can apply quartile deviation, because if you remember, if we are having the continuous distribution, then such kind of graph that we draw with a normal curve, histogram with a normal curve, and here is suppose our mean, here is minimum, here is maximum, and in on this line we can find q1, say that q2 and q3 and 4 equal parts. Fine, so usually the quartile deviation we can apply on the scale data only. Now let me take you to the scale data then. So here is the age, and in the age, what does it mean? It means that suppose here is the minimum value, here is the maximum value, and if I plot q1 here, q2 here and q3 here, then my q3 is 47 and that is the age, q1 is 28, that's fine, and 9.5, what does that mean? It means these both the quartiles, they are averagely far from this median by 9.5 years, because this age is in the years. So averagely how far they are? This 47 and 28, they are averagely 9.5 years far from the median. So median is important. Median is important. They both are far from this median. They both are far from this median. And how much they are far? 9.5 years. Why I am calling it years? Because this my variable is in years. All the responses here, they are in the years. So this is also important. We should know that how I have measured my variable. So that part is also a very important part. Now again, if I come to HC, I cannot give any meaning to this, because this HC is a coded data, categorical data, fine, kind of a ordinal variable. So I cannot apply quartile deviation on this, but I can apply quartile deviation on the scale variable, that is age. Now if I go further, here you can see that, you can look here, that here is your quartile 1, here is your quartile 3, fine. So here is 25% distribution, here is a 25% distribution, and if I draw a line, here is 25 distribution, here is 25% distribution. Now what is quartile deviation? 9.5 means this number, that is 47, and this number, that is 28, they are averagely 9.5 years far from this median, because q2 is median. So this distance, the average distance is 9.5. 9.5. So this is the way that we interpret quartile deviation. Now let me take you all to the standard deviation. What is standard deviation? Standard deviation is average scatter around the mean. And we already have discussed on this, that the meaning of standard deviation and some important points already we have discussed. See, in the standard deviation, two things are there. If the scatter is near to this central point, then your standard deviation is small. And if this scatter is spread, means if there is a huge spread, then your standard deviation is high. So all these points we already have discussed in the previous lecture. Now let me take you all to the output. How to compute standard deviation? There is inbuilt formula in the MS Excel. For that we give equal to sign, STDEV is the function. We select the range and we press enter, and to compute standard deviation for other variables, I'll just drag this formula to the end, and for the other variables again we got the output for the standard deviation. Now let me take you all to the reading and interpretation of the standard deviation. Here also again we'll first consider the nominal variables. So far nominal variables are concerned, again here is the error message because this is a string data. Now so far the gender C is concerned, standard deviation is 0.500. It has no meaning because this is not a continuous frequency distribution, and this is just a coded data. We are having only two things, 0 and 1. Fine. So how to compute this? No, we cannot compute. Means we cannot give proper meaning to this standard deviation. Standard deviation is only applied to any variable, for which variable if we are able to compute x bar. What I mean to say, if we compute x bar for any particular variable, wherever we compute x bar, there we can compute standard deviation. Again I repeat, wherever we are able to compute x bar, wherever we are able to read and interpret the x bar, in all those places we are able to compute standard deviation, and we all are able to read and interpret that part. So if any variable we are computing x bar, there we can compute standard deviation. Now let me take you to the ordinal variable. Here also, in ordinal variable also, we cannot give proper meaning to this statistic. Reasons are simple. We are not able to compute x bar on the ordinal data. We never ever can give meaning to the values. Which values? If we compute x bar, that is arithmetic mean, on the ordinal variable, then we cannot give proper meaning to this. And that is the reason that if we are not able to compute x bar, then we cannot go for the standard deviation, because we cannot give proper meaning to this number. Is it fine? Fine. Now let me take you all to the scale variable. In the scale variable, standard deviation is 12.19. Now how to interpret this? To interpret this, let me take you to the graph. Now how much is the mean? 36.94. Where it is located? It is almost here, 37. Say that 37. Now what is the meaning of this 12.19? 12.19 simply tells me that from this mean, the average spread on the both the sides, average spread on the right side, where we are having the higher numbers than this mean, and on the left side where we are having the less numbers than this mean, the average spread, average distance, average variation is almost 12.19 years. So averagely the dispersion here is the 12.19. Then I can say that if my mean is 37 with the standard deviation plus and minus 12.19, what does that mean? It means that the average spread of my data is 12 years almost. Now suppose if someone else comes in and if he says that his mean average age is 37 and standard deviation is just, say that, plus or minus 6.2 years, say that, then here the graph is like this, and here the graph is like this. Here you will find the more spread. Here is standard deviation is more, here it is a large number, and here the standard deviation is small because the spread is small. And what is the spread? What does that mean? Spread means this thing, like this histogram with normal curve. Fine. So here is your mean, and from the mean this spread is of about 12.19. So this is the way that we interpret this value. Fine. So we can apply standard deviation on only scale variable. We cannot apply standard deviation on nominal or ordinal variable. So let me now take you all to the reading and interpretation of other variables. So what is the maximum height? That is 183 centimeter. Minimum height 155. What is the difference between these two? That is 28 centimeters difference. It is there. Quartile 3 is 171 and quartile 1 is 164. So 50% of the distribution it lies between these 2 points. 50% distribution lies between these 2 points. Quartile deviation, that is the average distance of this number and this number. Average distance of these quartiles from the median is 3.12. Again, quartile deviation, when we are trying to give meaning to quartile deviation, always use word median. This is a distance from the median, average distance from the median. And when we are giving meaning to the standard deviation, this is actually the spread from the mean, arithmetic mean. And arithmetic mean and median are different concepts. Please pay attention to this thing. Now come to weight. Again here range is 61. So 61 is nothing but the difference between these two values. Fine. So here is quartile deviation 7.12. What does that mean? It means these two numbers 72 and 57.75, quartile 3 and quartile 1, they are averagely 7.12 kg far from the median. So this is actually like if here is q1, here it is q3, here is your median. So this distance is averagely 7.12, both the sides. This is the way that we interpret this value. Now let me talk on standard deviation. What is standard deviation? 12.56. What does that mean? It means whatever is my mean, the average spread on both the sides is 12.56 kg. On both the sides, 12.56 kg. Fine. Now come to income. In the case of income, highest income is 87,000, lowest is 22,000 rupees. So the difference between both is 85,000. Now quartile deviation is 9375. What does that mean? It means again both the quartiles averagely they vary averagely with the 9,375 rupees. So this is the distance from the median, average distance from the median. Distance of whom? Distance of both the quartiles. Fine. And this is the standard deviation. What does that mean? Standard deviation. Suppose here is my mean, averagely 17,973 rupees. On the right hand side there is that dispersion is there, and on the left hand side also around 17,973, that much dispersion is there. So this is the way that we actually read and interpret data, read and interpret the dispersion values. Now let me take you to the further slide. If I compare MS Excel output and S.P.S.S output, as mentioned earlier in the earlier lectures, that the outputs are same, so don't bother for the results. Means if you are comfortable with MS Excel, we can compute the things using MS Excel. If you are comfortable in S.P.S.S, go to S.P.S.S. You will get the same results. There will be no there won't be any difference. Fine. For example, here standard deviation is 0.501. You can see that 50. Actually 50 it is here. We cannot give meaning to this because this is just a nominal variable. Even for satisfaction also, this is a nominal variable. So don't consider these values. Don't consider these values. Let me take you all to the age. So here is max 68. Where is the maximum here? Maximum is mentioned here, 68. So minimum 14, 54 is the range. Here is the 54 range. Fine. Then third quartile, fourth quartile, we compute here considering the percentile 25th and 75th. Fine. So it is 28. It is 47. So here is a 28, that is quartile 1. 25th percentile is actually quartile. This is quartile 1. Fine. And this is quartile 3, 75th percentile, that is 47. So 47 is also here. Fine. And when we compute quartile deviation, here also we can compute quartile deviation by deducting 28 from 47 divided by 2. Standard deviation 12.19. Here is 12.19. So don't bother for the don't bother for the MS, whether to use to MS Excel or whether to use S.P.S.S. Don't bother for that. Whichever is suited to you, wherever you are comfortable, use that particular thing. And I hope you understood this lecture. In this lecture we tried to make you familiar with the reading and interpretation of the dispersion values. I hope you enjoyed this lecture. See you soon in the next lecture. Till then, thank you.